Hello everyone and welcome back to Exam Ignite YouTube channel. This is a part 2 video of the module 1 of the embedded system design subject. So here we'll be starting with the memory. So memory, it is an important part of a processor or a controller based embedded system that is used for what? Storing, controlling the algorithms, program instructions and the temporary data. So what are the types of memory? We are having two types. One is ROM and RAM. Program storage memory is our ROM, and the read or write memory, that is a random access memory, that is ROM. So first one, program storage memory, that is our ROM. So here it stores the program instructions of the embedded system. This has non-volatile memory, and it is used to store the firmware or the control algorithm, that is a software. So inside the ROM we are having again six types. One is masked ROM, then programmable ROM, erasable programmable ROM, electrically erasable programmable ROM, flash memory, and NVRAM. Each one will be discussing now. Masked ROM. This is a one-time programmable memory programmed by the manufacturer. That is, in the factory itself, it is programmed, low cost for the mass production, and the software cannot be modified once it is programmed. Low cost and cannot be updated or reprogrammed. Next comes the PROM, that is programmable. So here it is programmed by the end user only once. So once you can alter it. Programmed using the PROM, programmable ROM programmer. So it uses a nichrome or a polysilicon wires as fuses, and this cannot be reprogrammed again. So next comes erasable programmable read-only memory. Here the memory can be erased or reprogrammed. These this uses a floating gate, that is FET, erased using the ultraviolet rays, that is UV rays. Entire memory gets erased at once. You can erase it and you can rewrite it, but it is slow and time consuming. Electrically erasable means here it is erased electrically and then reprogrammed. You can erase it byte by byte, then supports in circuit programming and faster than the EEPROM. Next comes flash memory. Here flash memory is an advanced ROM technology and a variation of the EEPROM. So high capacity storage, it has an organized as blocks and pages, erase sector or page wise before reprogramming. What part you want, you can erase it. Most popular ROM in the embedded system that we are using is this flash memory. Next is NVROM. This is a non-volatile RAM, is a random access memory with a battery backup. So this will retain the data even without power supply, and it is used for storing the operation results and the status flags, battery and memory packed together. Next comes the read-write memory, that is random access memory RAM. It is a working memory of the controller or a processor that is used for storing the temporary data during the execution. This is a volatile, that is data is lost once the power is off. It supports the read and write operation. There is a direct access to the memory location. Again, we are having three types of RAM. One is static RAM, dynamic RAM, and NVRAM. Static RAM. So this stores the data in the form of volatile using the flip-flops. This is faster than the dynamic RAM because it is built using the 6 MOSFETs, that is 6 transistor set. No refreshing is required. Fast operation, high speed access, but it is costly and low storage density. So this is an SRAM cell representation and the visualization of the SRAM cell. Next comes dynamic RAM, that is dynamic RAM, that we call RAM, that is stores data in the form of charge. This is built using the MOSFET and capacitors. Requires periodic refreshing, high storage density. Advantages is high capacity, low cost, then slower than the SRAM due to the refresh requirement. So this is how the cell is implemented. You need to know the difference between the SRAM and DRAM. It is made up of 6 CMOS transistors. This is made up of MOSFET and capacitor. No refreshing required. Here refreshing is required. Low capacity, high capacity, more expensive, and this is less expensive. Faster operation in SRAM and slower operation in DRAM. NVRAM is a non-volatile RAM with the battery backup, as we learned before, stores the data even during the power failure. Used for the non-volatile storage of the operation results and flags. Lifespan is approximately 10 years. Memory according to the type of interface we do. We are having two types of interface. One is parallel interface and serial interface. In the parallel, this uses multiple data lines for communication. 8-bit processor uses D0 to D7 lines. Higher memory density and memory capacity usually expressed in kilobytes. Next comes serial interface. Here uses serial communication protocol. That is I2C, SPI, and one wire. We'll be learning all these three serial interfaces in this module. Next, in the most used EEPROM memory and requires fewer connection lines. Next comes memory shadowing. It's a technique in which the ROM content is copied to the RAM to improve the execution speed. Whole RAM content is sent to the RAM. Here, need for the memory shadowing. Here, ROM execution is slower compared to the RAM. So, RAM is approximately 3 times faster than the ROM. So, during the system boot up, BIOS or the program is stored in the ROM is copied to the RAM. After copying, the execution occurs from the RAM instead of the ROM. So this improves the system performance and the execution speed. Next is memory selection for the embedded system. So what are the factors that you need to consider while selecting a memory for an embedded system? First thing is application requirement, for what is required. Processor or the controller type, then RAM or ROM memory requirement. What is the size of the memory or the capacity? Address range supported by the processor, word size of memory, then comes the operating environment. So ROM selection has to be done by flash memories commonly used to program storage for the program storage. We are having two types. One is NAND flash and NOR flash. In the NAND flash, high density, low cost and used for the storage. NOR flash, it supports execute in place but faster execution. Next comes EEPROM selection. It is available as a serial or the parallel interface chip. So serial is preferred for the lower applications and fewer connections. Next comes the sensors and actuators. An important topic, you will be asked to write a short note on the sensors and actuators. So the embedded systems interact with the real world with these two main components. So since sensors are connected to the input ports and actuators are connected to the output ports. Sensor will detect the changes in the environment and actuators perform the control actions. So what is sensors? It is a transducer device that converts energy from one form to the another for the measurement or control purpose. So function is it detects the environmental changes, sends the input to the embedded system, and it is used for the measurement and monitoring. What are the examples? Is accelerometer sensor, that is speedometer in the smartwatch, then the ambient light sensor that measures the light intensity. Next comes actuators. So it is a mechanical or an electrical transducer that converts the signal into a physical action. That is acts as an output device, produces a physical movement or action. In the smartwatch, adjusts the brightness automatically using an actuator. Next comes the input-output subsystem, one of the important topic here, where you need to know each one of the input-output devices explanation to write in the exam. So this facilitates the interaction of embedded system with the external world, both the input-output subsystem. So we know the sensors and actuators help in that. So first is the device is LED, light emitting diode. It is an important output device used for the visual indication in an embedded system. So function is it indicates the system status, that is device used for the signals like the device is on or the battery is low, battery is charging to indicate that. So this is just a PN junction diode that contains an anode that is plus terminal and a cathode that is negative terminal. Current limiting resistor is connected in series to maintain the safety of the LED. Next comes LED interfacing method. So here anode is connected to the port pin, that is port source current, then LED on at the logic high. When it is 1, LED is turned on. Cathode is connected to the port pin, that is port sinks current. LED is on at the logic 0. Based on the two types of interfacing methods, it depends. Next, 7-segment LED display. Here, 7-segment display, LED display is an output device used for displaying the alphanumeric characters. So it contains 8 LED segments arranged specifically. That is from A, B, C, D, E, F, G, and D, P. That is decimal point. Used to display the numbers and characters. So public telephone call monitors or the point of sale terminals. So we are having again types of 7-segment display: common anode and common cathode. In the common anode, it glows at 0. In the common cathode, it glows at 1. So this is a 7-segment LED display, how it looks. And this is a common anode and cathode configurations of a 7-segment LED display. Next comes the optocoupler. So here it is a solid state device used to isolate the two parts of a circuit that combines an LED and a phototransistor. So this provides an electrical isolation, noise suppression, or the current isolation, circuit isolation, or signal transfer, or some of the applications. So this is an optocoupler where we are having an LED and a phototransistor. So this is an optocoupler in the input and output circuit. You need to write this when you are asked for to explain an optocoupler. Next is stepper motor. It is an electromechanical device which produces a discrete rotational motion in response to the electrical signals. So step-by-step motion is produced. So widely used in the industrial systems, robotics, consumer electronics, and the printers machines. Types, we are having unipolar stepper motor or bipolar stepper motor. Unipolar means it contains two windings per phase. Direction is controlled by changing the current flow and it is easier to control. This is a two-phase unipolar stepper motor. So step modes are full step mode and wave step mode and half step mode. These are the different modes. In full step mode, both the phases energize simultaneously. Wave means only one phase is energized. Half phase means combination of the wave as well as the full step. Interfacing. So interfaced during the driver IC ULN2803 and it is connected between a microcontroller and a motor. So next is a relay. Relay is an electromechanical device that is used as a dynamic path selector for a signals and power. How it is constructed? By using a relay coil, metal armature and one or more contacts. So how does it work? Works on an electromagnetic principle. When the voltage is applied to a relay coil, the current will flow and it produces a magnetic field. So that magnetic field attracts the armature and changes the contact position. So this changes the signal or power flow path. So we are having different types of relay configuration. First one is single pole, single through, normally open, that is SPST and O. So here circuit is normally open and becomes closed when the relay is energized. Second one is single pole, single through, normally closed. So here the circuit is normally closed and becomes open when it is energized. Reverse to the first one. Third one is single pole double through. Here has two paths for the signal flow. So selected by the energizing or the de-energizing relay. So next is the relay interfacing. So here it is controlled by the relay driver circuit is connected to the processor port pin. Transistor is used for the driving relay and the freewheeling diode is used to protect the transistor and relay from the reverse voltage. So this is a transistor based relay driving circuit. Next comes the piezo buzzer. Here it is used for generating the audio indications in an embedded applications. So that the features here, it produces the sound when the voltage is applied. So it contains a piezoelectronic diaphragm used for warning and the alert indications. So we are having two types, one is self-driving and external driving. Self-driving means it generates predefined tone automatically. External driving, it supports different tones by varying the pulse train. Interfacing, it can be directly interfaced to the processor pin, then can also use as transistor-based driver circuit. Next comes push button switch. Here it is an input device used for generating a momentary pulse signals. So we are having two types. One is push to make and push to break. If you push that push button, it normally opens or the circuit closes when it is pressed. Push to break means here normally closed. When you press, the circuit opens. Features, here it is used to reset the switch or as a start switch you can use. It generates high pulse or the low pulse. So this is a push button switch configuration. Then comes the keyboard. You know, it is an input device used for the interfacing. We are having it is used for entering the data and the commands. We are having large number of keys. They are arranged in a matrix form and it reduces the number of interface connections. So the matrix keyboard, it is arranged in the rows and columns, that is 4x4 matrix, and it's working and all. Next is programmable peripheral interface. So it is a device that is used for extending the input-output capabilities of the processor. So this expands the I/O ports of processor or a controller, supports a 24 input-output pins. So example is given A to 5IA PPI. Ports are given here. Port A means 8-bit port, port B means 8-bit port, and port C splits into two. One is upper port and another is lower port. So this is how the interfacing of a 8255 with the 8-bit microcontroller. Next is the communication interface. So it is used for communication between the various subsystems of a embedded system with the external world. So we are having two types. One is onboard communication interface and the external communication interface. Onboard means here it is between the components within the embedded system here. Embedded system itself. Example is I2C, SPI, UART, one-wire interface, and parallel bus interfaces. These are the examples of onboard communication interface. External communication interface means it is with the external devices. like the Bluetooth, Wi-Fi, USB, RS-232, and Ethernet. So on board, first we'll discuss and then we'll move on to the external. So first one is I2C bus. Here it is a synchronous bidirectional half duplex serial communication bus. It is developed by the Philips Semiconductor and it is uses two-wire serial interface, supports the multiple master and slave devices. It is used for the communication between the microcontroller and peripheral devices. I2C bus lines, we are having two lines. One is SCL, serial clock line, and SDA, serial data line. That generates the synchronization clock pulse, and this is used for the serial data transfer. Master device controls the communication. Slave responds to the master command, and data is transferred to the SDA line, synchronized with the SCL line. So major advantages, it requires only two wires, supports multiple devices. So this is the I2C bus interfacing. So this is our microcontroller and the port pins. We connect the two with the two wires, one to the SDA and to the SCL. So next is serial peripheral interface, that is SPI bus. This is a synchronous bidirectional full duplex 4-wire serial communication bus. So you need to remember the keywords here. It is a synchronous bidirectional full duplex and the 4-wire serial communication bus. Here it is introduced by the Motorola and supports single master and multiple slave devices. High-speed serial communication. SPI signal lines means MOSI, that is master out, slave in. Data transfers from master to slave. In the MISO, master in, slave out, reverse, that is slave to master. Then comes SCL, that is serial clock, then clock signal line, and then SS, that is slave select, selects the slave device. So working here, master generates the clock signal, data is transferred using the shift register mechanism. Communication is possible in both the directions simultaneously. So this is our SPI bus interfacing. So this is my microcontroller or the microprocessor, my slave 1 and slave 2, using the different MOSI or MISO or SCL or SS, we connect it. These are all the SPI bus. Next comes the Universal Asynchronous Receiver Transmitter, that is UART. It is an asynchronous serial communication interface used for the serial data transmission. This does not require clock signal for synchronization, uses only the baud rate for communication, supports a serial transmission and reception. Then UART lines are two lines. One is RxD and TXD. TXD for transmitting data and RxD for receiving the data. Working how it works. So data transmitted between the start bit, data bits, parity bit, and stop bit. So transmitter TX is connected to the receiver. UART chip, this is a UART interfacing. So here you can observe TXT to RxD, then TXT to RxD. TXT means transmitter line, RxD means receiver line. One wire interface. It is an asynchronous half duplex communication protocol developed by the Maxine Dallas Semiconductor. So what are the features here is it uses a single line for communication, follows a master slave communication model, one master and one or more slave devices. Here, master will send the reset pulse, then slave will respond to the presence pulse, then master sends the ROM command and address of the slave device. So read or write command is initiated, data transfer takes place. So this requires only one wire and supports multiple slave devices. So this is our one wire interface bus. Next comes parallel interface. Here it is a communication with the memory mapped peripheral devices, uses parallel data bus, high-speed data transfer. It is controlled by read signal, write signal, or chip select signals. So host processor selects the device using the chip select signal. Data is transferred to the parallel bus and communication is controlled by the read or write signals. Then external communication interfaces, that is RS-232, RS-422, and RS-485. So that the differences between these different interfaces is RS-232, it is a wired asynchronous serial communication interface developed by the EIE, that is Electronic Industries Association. So here it uses UART communication, point-to-point communication. It uses RxD and TXD for transmission and reception. This supports DB9 and DB25 connectors. So this is the DB9 and DB25 connector interface. Next, advantages is simple serial communication used in the industrial application that is not suitable for multi-drop communication. Next, RS-422, it is a different serial communication standards. This supports a data rate up to 100 kbps, and communication distance is different, and it supports a multi-drop communication. It overcomes the previous one. Next is RS485. Here it is an enhanced version of the RS422. It supports a multi-drop communication and supports to 32 transmitting devices and 32 receiving devices. Uses addressing mechanism to identify the slave devices. Long distance communication is achieved. Universal Serial Bus, that is USB, is a wired high-speed serial communication bus used for the data communication. What does it use? It uses star topology. One USB host, there is a hub, that is a USB host connected to the multiple peripheral devices like 1, 2, 3. Then USB 2.0 supports up to 127 devices. Communication is initiated by the host device and supports high speed data transfer. Next is USB cable pins. Here V bus, that is power supply, is 5 volts. Then D minus, here it is a differential data line, and D plus is differential data line, ground line. So high speed communication, so better noise immunity, supports power supply to devices. What are the types of data transfer? Control transfer, bulk transfer, isochronous transfer, then interrupting transfer. We are using different USB versions for the speeds, then connectors, type A, type B, or type C, then applications of that. Then comes the IEEE 1394 Firewire. So this is a wired isochronous high speed serial communication bus. And also next is infrared IRDA. So here it is a wireless line of sight serial communication technology for data communication devices. So this uses infrared light for the communication. Point to point and point to multi-point communication requires line of sight communication and low cost communication technology. So this range from 10 centimeter to 1 meter. So we are having different types of IR also. Then comes Bluetooth. It is a low cost, low power, short range wireless communication technology used for the data and audio communication. So it operates at the radio frequency band of 2.4 gigahertz. Uses a frequency hopping spread spectrum technique. So it supports point to point as well as point to multi-point communication. Works on the master-slave relationship. It uses packet-based data transfer. Range is 30 to 100 feet. Then comes the next one is Wi-Fi. So Wi-Fi is nothing but wireless fidelity. It is a wireless communication technology used for the network communication between the devices. Based on the IEEE 80211 standards, it is given. Then supports the IP communication, Internet Protocol communication, uses Wi-Fi router or access points. So devices are identified using the IP address. It supports the wireless data transmission using the radio signals. Its frequency operates at 2.4 gigahertz, 5 gigahertz. Data rate is 1 Mbps to 1300 Mbps. Then comes the next one is Zigbee. That is, here it is a low power, low cost wireless communication protocol based on the standard. So here it is designed for low power and low data rate application, supports some mesh networking, and it is reliable wireless communication. Frequency band is 2.4 gigahertz, 902 to 928 megahertz, then 868 megahertz. Data rate 20 kbps to 250 kbps. Range is up to 100 meter. We are having different categories. You can go through it. Next comes General Packet Radio Service, that is GPRS, 3G, 4G, or LTE. They are all the cellular communication technologies used for transmitting the data over the mobile communication networks. So data are sent as packets, supports the IP and PPP protocols used in the GSM and CDMA networks. Then maximum theoretical data rate is 171.2 kbps. We are having 3G, where data it is a higher band communication, 4G or LTE, which is a high speed communication technology. Next comes the last topic, that is an embedded firmware. So it refers to control algorithm and a configuration setting dumped into a program memory of an embedded system. So it is stored in the program or code memory, essential part of an embedded system, and it controls the system operation. What are the methods for developing an embedded firmware or embedded software? One thing, we need a high-level programming language or an assembly language programming. Firstly, it uses an embedded C or C++ that is developed in an IDE, that is integrated development environment. What does it contain? It contains an editor, compiler, linker, debugger, and simulator. Then what is assembly language programming? It uses a processor and controller specific instruction, but it is hardware dependent and difficult and time consuming. HEX file will be created once we write a program in high language or in assembly language that is converted to the machine readable binary code. So that file is called as an HEX file that is loaded into my program memory. So we are having two types of control algorithms. One is super loop based approach and one is OS based. Super loop means control flows through top to bottom repeatedly. OS based means uses GPOS or RTOS scheduler for the task execution. Some of the other system components we can see here is, why do we need this? This is required for the proper functioning of a processor or my software execution. Some of the components is reset circuit we need brownout protection circuit, we need oscillator unit, we need our real-time clock, that is RTC, then watchdog timer unit. Firstly, reset circuit. This is to initialize the processor to a known state during the power on or reset condition. So this resets the internal registers. It starts the software execution from the reset vector, ensures there is a proper startup. Again, we are having two types reset signal. One is active high reset and active low reset. This can be external passive reset circuit or reset pulse width control using the resistors or capacitors can also be done. So this is my RC based reset circuit, how to write it. Next is brownout protection circuit. So this prevents the unexpected processor behavior when the supply voltage falls below the specified threshold. So if it falls down than the specified threshold, then it holds the processor in the reset state when the voltage is low. It prevents the data corruption and unexpected operation. This uses a Zener diode and a transistor. This is available as a supervisor IC. So you can say this is my brownout protection circuit with active low output. Next is oscillator unit. Here it generates the clock signal required for the processor and controller operation. So synchronizes instruction execution, uses a quartz crystal resonator, ceramic resonator, and an external oscillator chip. Clock frequency affects the processor time. So here this is an oscillator circuitry using the quartz crystal and a quartz crystal oscillator. Next is the real-time clock RTC. It is a system component responsible for keeping track of time, which stores the current time, data, day, month, year, everything. It provides a timing reference to the embedded system, works even without main power supply using the backup battery. It is available as an IC chips for manufacturers and it contains the microchip. So next is the watchdog timer. This is a hardware timer that is used for monitoring the firmware execution, that is software execution, and resetting the processor when the system hangs or behaves abnormally. So it monitors the software execution, detects the program hang or infinite loop, abnormal system behavior, and resets the processor automatically. Working as watchdog contains a free running counter increments or decrements continuously. Firmware should periodically reset the watchdog. If the firmware fails to reset in the time, then processor gets reset automatically. Then features here is it prevents the system crash, improves the system reliability. So this is my watchdog timer for firmware execution and supervision. Next is PCB and passive components. So this is a PCB is a very backbone of every embedded system used for mounting and interconnecting the components according to circuit design. So what do? They mount all the required components, provides an electrical interconnection between the components, helps in the proper functioning. So passive components used in the embedded system like the resistors, capacitors, diode, regulator IC or spike suppressor filter capacitors. So what is the importance that it provides a regulated ripple-free power supply, essential for the proper operation of an embedded system. So this completes the module 1. So I hope I have covered all the topics that are mentioned in the syllabus copy. So this completes it. Thank you for watching. Please do like, share and subscribe to Exam Ignite.